In question 2, we're comparing the results of a class between mathematics mark and a history mark. And we want the probability, looking at the question here, what's the probability that the student scored more than 10 marks? And as long as we understand that 10 is not included in more than 10, we should be fine. So in mathematics, more than 10, we can see that it occurs a few times. And in fact, we can see that it occurs almost all of the time. So we could count up all of these, but another method is to use the complement. Instead of looking at the ones that do score more marks, let's look at the ones that do not score more than 10 marks. So we can see that there are only 2 here. So we're aware that there are 12 students in the class. So let's use the complement property and say it's going to be 1 minus 2 out of 12. And if we do some simplification, that's 1 minus 1 over 6. And so this is going to be 5 over 6. So we could have counted up all of the scores, but the complement property is often an easier way to solve these sort of problems because the number is fewer. So just to check, I mean, if we count all of the other ones here, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could have counted them up, so we could say, or we could have said 10 out of the 12, and we get the same answer when we simplify by dividing by 2 here in the numerator and denominator. So 2 equally good methods to solve that question there. Okay, so in mathematics, in the next question, mathematics and history, and is the important word. So in both the, will we count student A? No, because it's not less than, still in more than 10 marks we're interested in. So we can see that also C is not counted. We can see E, where else? H, J, and K. So we can see that there are 4 out of the 12. We should always simplify if we can. We can see 4 goes into both of these numbers. So 1 out of 3, or 1/3 is the probability that they will have more than 10 marks in mathematics and in history. The next question we're looking for at least 1. So at least. Well, we could go through and just check each one as we go. So for A, do they have at least 1? Well, yes, they have A, so yeah. The mathematics, yep, so that's good. We could check B. Okay, yep. But we can see that most of the students actually do have at least 1 subject more than 10. So what's going to be easier in this case is the complement property. So we can say 1 minus both less than 10. So in this case, that's going to make it a lot easier for us. As we quickly scan across the students, we can see that, in fact, everybody has at least 1 subject that's more than 10. So in this case, it's the 1 minus 0, and so our answer is actually 1 is the probability. It's actually certain that if we pick a student then at random, then they'll have at least 1 subject with more than 10 marks. So we can see, just summing up, the complement property was used in part I and part III. And when we had something that we could count easily, we just did normal basic probability as in part 2.